Okay, so welcome members today. Today we are going to see a new topic called vectors. Now we start by defining what a vector is. A vector is a quantity which has a direction and also a magnitude. So like this, and the vector AB is noted by, we either use an arrow here or we use this symbol, sometimes people call it a small tail. So this is how we denote a vector with either this arrow or that symbol. Now, from there we look to what we call a position vector and a column vector. Now, if I have a point x, y, if I want its distance from the origin we call it O to represent the origin. So its distance from the origin to that point is what we call a position vector, so that it will be OA. So my OA, we can represent it with a small a. From my point A, we get a small a, which we can say now the position vector of this, now we convert it into a column vector, and that's what we call a column vector. So this point x, y, I can write it into a column form of x and y, x, y. So, if I want you to get now the column vectors, I mean the position vectors of this, you just write them as column vectors. So the position vector of A, it will be OA. From here, I can get the position vectors of these 3 points, like this. So that's how I get those position vectors. Of course, I put these ones to show that those are vectors. Now, we move to the dimensions of vectors. For now, we have 3 dimensions and 2 dimensions. Some people can say 1 dimension, but that one is really... So the 2 dimensions is where we have the x and y. Now, we can also represent the vectors in the ijk notation. So if we are having 2, it means that we have on the x-axis, it is given by I, on the y-axis given by j. So if I have OA equal to xi plus yi, this is how I can give you this vector. Now in 2 dimension, now we bring in another axis, what we call the z-axis. Now here it's I on the x, j on the y, and now k on the z-axis. So if I give you a vector OA equal to this and this, its position vector, it will be now x, y, z, like that. So for here, if you have the ijk notation, we are summing those coordinates. Now, you also see that whenever I have I put a symbol so that it's a vector. For I, we either use what we call a cap, like this, or we use I, but in some it's like they don't write this, they just write them as bold letters, bold small letters of I and K. So from there, we must move to algebra of a vector. Algebra of a vector, I mean, how do we add 2 vectors? How do we subtract 2 vectors? Can we multiply a scalar and a vector? We are going to see. So here I give you, if A is this and B is this, find A plus B, A minus B, then 3A, and so on. Now, to see, you first check, you see that this one I have ik. It means that now they are giving me a vector of 3 coordinates. Even here, I mean of 3 points. Of 3 coordinates. Then B is here, is in ijk. So meaning that now I first write them as position vectors. So from here, start my A is, now I write it as 3. You start here, I'm missing the J. Mean that the j is 0, here I'm having -2. Then my b is, from here I have 2, 3, then -5. So meaning, if I'm going to one, I want a plus b, it will be now 3, 0, -2, the a, then plus the b, which is 2, 3, -5. Now add the vectors, you just add. The x, you add the x, the y with the y, the z with the z coordinate, like that. Then if you are in 2 dimension. So meaning 3 plus 2, I'll be having a 5. then 0 plus 3, I'll be having now a 3, then negative 2 plus negative 5, I'll be having negative 7, which you can give as now in the ideal notation as 5i plus 3j, then minus 7k. When I come to my note 2, I want a minus b. A minus b, just substitute 3, 0, negative 2 plus 2, 3, negative 5. This time I'm subtracting. So now you see, this minus this I get 1, 0 minus 3, I get negative 3, then negative 2 minus, I have negative 2 plus now 5, which will be a 3. Now in the ideal notation, this is now 1, which you can just write as I, minus 3j, then plus 3k. So in number 3, they want me to get 3a. So start they are multiplying a with the scalar 3, then plus 4b. Also vector b they are multiplying. Now we can multiply a scalar with a vector. So this will be now 3 into my a, which is 3, 0, negative 2, then plus 4 into my 2, 3, negative 5. So if you multiply there, start we shall be having, you multiply the way we multiply. This times this will be 9, 3 times this you get 0, 3 times this you get negative 6. Now plus, you first always multiply. So this times this you get 8, you get 12, you get negative 20. And now if you add those two, you see that you have 9 plus 8, that will give you a 17. Then 0 plus 12 is 12, then negative 6 plus negative 20, negative 26, which you can write in the ideal notation as 17i plus 12j minus 26k. But you show that these are vectors, or you show that you include those, show that those are vectors. So members, now we try 4 and 5 like this. I wish you the best. That's the first part of vectors. Don't forget to subscribe to the channel.